Hi students, good morning everybody. In the previous lecture, we have seen fundamental identities, means fundamental identities of trigonometric functions, in which we have studied 1 plus tan square theta is equal to sec square theta. Also 1 plus cot square theta is equal to cosec square theta. Sin square theta plus cos square theta is equal to 1. These three fundamental identities which we have studied in the last lecture. Also in the last lecture we have seen relation between Cartesian coordinates and polar coordinates. See, if r comma theta, these are the polar coordinates of a point in the plane, and x comma y, these are Cartesian coordinates then we have a relation between Cartesian coordinates and polar coordinates, and that relation is x is equal to r cos theta and y is equal to r sin theta. With the help of these two equations, as well as we have one more equation, that is tan theta is equal to y by x. This, with the help of these three equations, if Cartesian coordinates are given, we can find polar coordinates, or if polar coordinates are given, we can find Cartesian coordinates. Okay, now today we are going to see the exercise or the problems or examples from the exercise which are depends upon these concepts. Okay, now let's start. First question: eliminate theta if x is equal to 3 sec theta 3 sec theta and y is equal to 4 tan theta. So now here we have to eliminate theta from these equations. So to eliminate theta, we have to make the use of fundamental identities. So we have, let what is given, x is equal to 3 sec theta and y is equal to 4 tan theta. So we have, or if we shift this 3 to left hand side, so we get x upon 3 is equal to sec theta, and if we shift this 4 to left hand side, we get y upon 4 is equal to tan theta. It means sec theta is equal to x upon 3 and tan theta is equal to y upon 4. We have, what we have, 1 plus tan square theta is equal to sec square theta. It means sec square theta minus tan square theta is equal to 1. So now we have the values of sec theta and tan theta. Sec theta is x upon 3 and tan theta is y upon 4. Put these values of sec theta and tan theta in this equation. So we get x upon 3 bracket square minus y upon 4 bracket square is equal to 1. That is x square divided by 9 minus y square divided by 16 is equal to 1. And observe this equation. X square upon 9 minus y square divided by 16 is equal to 1. In this equation, theta is absent. So we have eliminated theta. Next question. Eliminate theta if x is equal to 6 cosec theta and y is equal to 8 cot theta. So second sub question, the answer for this question. Let x is equal to 6 cosec theta and y is equal to 8 cot theta. So from this one here, x upon 6 is equal to cosec theta and y upon 8 is equal to cot theta. So we have one of the fundamental identity. We have 1 plus cot square theta is equal to cosec square theta. From this one, cosec square theta minus cot square theta is equal to 1. And now here put the values of cosec theta and cot theta. So it is x upon 6 bracket square minus y upon 8 bracket square is equal to 1. That is x square divided by 36 minus y square divided by 64 is equal to 1. And now observe this equation here, theta is eliminated. Now third sub question, eliminate theta if x is equal to 5 plus 6 cosec theta, 5 plus 6 cosec theta, and y is equal to 3 plus 8 cot theta. So see, let x is equal to 5 plus 6 cosec theta and y is equal to 3 plus 8 cot theta. See, now here shift this 5 to left hand side, so we get x minus 5 is equal to 6 cosec theta, as well as here y minus 3 is equal to 8 cot theta. Now divide throughout to this equation by 6, so we get x minus 5 divided by 6 is equal to cosec theta, and y minus 3 divided by 8 is equal to cot theta. And now we have the values of cot theta and cosec theta. Use fundamental identity. We have 1 plus cot square theta is equal to cosec square theta. It means cosec square theta minus cot square theta is equal to 1. Now put the values of cosec theta and cot theta. So it is x minus 5 divided by 6 bracket square minus y minus 3 divided by 8 bracket square is equal to 1. It means you can simplify by taking the square of first term as well as by taking the square of second term, but it is there is no need to expand further here, because already we have eliminated theta from this equation. Or if you want to write it, you may write it as x minus 5 bracket square divided by 36 minus y minus 3 bracket square divided by 64 is equal to 1, and hence we have eliminated the theta. So in this equation theta is absent, it means that we have eliminated theta. Okay, now next question number 2. See here, we have to find out the value of an acute angle theta such that this equation holds. 2 cos square theta is equal to 3 sin theta. It means that we have to find out if this equation holds at that time the value of theta. Okay, so let 2 cos square theta is equal to 3 sin theta. Now we have fundamental identity. Sin square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sin square theta. So here 2 into 1 minus sin square theta is equal to 3 into sin theta. Since cos square theta is equal to 1 minus sin square theta. Multiply to this bracket by 2, so it is 2 minus 2 sin square theta is equal to 3 sin theta. Shift this 3 sin theta to left hand side, so it is 2 minus 2 sin square theta minus 3 sin theta is equal to 0. Now multiply throughout to this equation by minus sign, so we get 2 sin square theta plus 3 sin theta, and this plus 2 become minus 2 is equal to 0. So now see, this is 2 sine square theta plus 3 sine theta minus 2 is equal to 0. This is quadratic equation in sine theta. If we put here sine theta is equal to m, then this equation becomes 2m square plus 3m minus 2 is equal to 0. So it is quadratic equation. Now factorize the middle term. So see, this is 2 into minus 2 become minus 4. So we have to factorize minus 4 whose subtraction is 3, and it is 4 and minus 1. So it is 2 sine square theta plus 4 sine theta minus sine theta minus 2 is equal to 0. If we take 2 sine theta common from first two terms, so if we take 2 sine theta, 2 sine theta, then it is sine theta plus 2. Now from the last two terms, take minus 1 common. If we take minus 1 common, so in bracket sine theta plus 2 is equal to 0. Now here it is sine theta plus 2, sine theta plus 2. Take sine theta plus 2 common. So sine theta plus 2 in another bracket 2 sine theta minus 1 is equal to 0. It means that here sine theta plus 2 is equal to 0, or 2 sine theta minus 1 is equal to 0. It means here sine theta is equal to minus 2, or 2 sine theta is equal to 1. It means sine theta is equal to minus 2, or sine theta is equal to 1 by 2. Now see here, we have two values of sine theta. That is minus 2 and another value is plus 2, plus 1 by 2. But we know that by the domain and range of sine function, trigonometric functions, you know that the values of sine theta always lies in between minus 1 and greater than minus 1, or 1 and less than plus 1. It means that since minus 1 is less than or equal to sine theta is less than or equal to 1, so therefore sine theta is not equal to minus 2. Sine theta never take the value minus 2. So therefore sine theta is not equal to minus 2. Now as sine theta is not equal to minus 2, it means that sine theta is equal to 1 by 2. So therefore sine theta is equal to 1 by 2. Now sine theta is equal to 1 by 2 and theta is acute angle. So therefore sine theta is equal to sine of 30 degree. You have to give the reason here, since theta is acute. So sine theta is equal to sine of 30 degree, so theta is equal to 30 degree, or pi by 6 radian. So this is the value of theta, or this is the acute angle theta which satisfies this equation. Okay, next question. Find polar coordinates. Find polar coordinates of point whose Cartesian coordinates are, coordinates are 5, 5. See here, we have to find out polar coordinates. Cartesian coordinates are given. Here, Cartesian coordinates are x comma y, and it is 5 comma 5. It means that x is equal to 5 and y is equal to 5. Let r comma theta be polar coordinates. We know that polar coordinates of the point whose Cartesian coordinates are x comma y are r comma theta. Let r comma theta be polar coordinates. So therefore we have x is equal to r cos theta and y is equal to r sin theta. So x is equal to or using this one, we know that x square plus y square is equal to, also we have one equation, x square plus y square is equal to r square, and tan theta is equal to y by x. So from the first equation, r square is equal to what is x here, 5, and y is also 5, so it is 5 square plus 5 square, means r square is equal to 25 plus 25. Here tan theta is equal to 5 divided by 5. It means here tan theta is equal to 1. So see, r square is equal to 25 plus 25, 50. It means r is equal to, or r square is equal to, we can write that 50 as 25 into 2. So r is equal to square root of 25 is 5 and square root of 2 is square root 2. So r is equal to 5 in square root 2. So we take here positive square root because this r is nothing but the distance of the point 5 comma 5 from the origin. So it is distance, so it is always positive. So r is equal to 5 in square root 2. Also we have see here one equation, tan theta is equal to 1. So tan theta is equal to 1. Now tan theta is equal to 1, it means tan theta is equal to, this 1 can be written as tan of 45 degree because tan 45 degree is 1. Now by using allied angles we can write another angle except this 45 degree, but see here, your 5 comma, the point on the terminal arm is 5 comma 5 and this point 5 comma 5 lies in first quadrant. It means your angle theta is acute angle, so we have to write here 45 degree. So tan theta is equal to tan of 45, or you may write the reason here also, theta is acute because point 5 comma 5, that point lies on the terminal arm and that point lies in first quadrant. It means your angle theta lies in first quadrant, means your angle theta is acute angle, so we write here 45 degree. So tan theta is equal to tan of 45 degree, so theta is equal to 45 degree or pi by 4 radian. So therefore polar coordinates of point 5 comma 5 are 5 in square root 2 comma 45 degree. So in this way, if Cartesian coordinates are given, we can find polar coordinates. Now we see in the next example that if polar coordinates are given, then how to find out Cartesian coordinates. Next example, find Cartesian coordinates. Cartesian coordinates of point whose polar coordinates are 3, 90 degree. Let polar coordinates See, r comma theta, these are polar coordinates, and here they are given as 3 comma 90 degree. So therefore r is equal to 3 and theta is equal to 90 degree. Let x comma y be Cartesian coordinates. So we have the relation between Cartesian coordinates and polar coordinates. X is equal to r cos theta and y is equal to r sin theta. So therefore x is equal to r, that is 3, into cos of 90 degree, and y is equal to 3 into sin of 90 degree. See, x is equal to 3 into cos of 90 degree, that is 0, and y is equal to 3 into sin of 90 degree, that is 1. So therefore x is equal to 3 into 0, 0, and y is equal to 3 into 1, that is 3. So therefore your Cartesian coordinates are 0 comma 3. So therefore the Cartesian coordinates of point 3 comma 90 degree are 0 comma 3. So in this way, if polar coordinates are given, we can find Cartesian coordinates.